thanks everybody for joining this session about getting under the hood of Patsnap GPT and our AI, addressing some concerns, highlighting some benefits, and why our model is more suitable to sort of be used in a live situation in an enterprise in the intellectual property and technology domains. Just going to navigate to my presentation. Okay, so Patsnap GPT. It offers reliable answers, faster action through innovation and IP-specific AI models. Picture this, you're an R&D leader or a patent attorney. You're swamped with technical documents, legal filings, deadlines, all while your competitors race ahead and the board is asking everybody to do more with less. This is where Patsnap GPT changes the game. It's not just another AI tool, it's the world's only derived proprietary model for patents, retrained on patents and journal data from the ground up. So it's not a fine-tune, it's a proper tier 2 novel model. It's purpose-built to deliver accurate, actionable insights, and it provides assistance, fast, reliable, specialized assistance to meet the needs of your field. Okay. So with over 200 million patents globally, and I just checked last year's numbers. In terms of total documents, we have 7 million new ones. It's hard to imagine a human team to be able to process all this data, let alone uncover insights from it. Add to this millions of academic papers, legal documents. It's really overwhelming. And the training of our model includes billions of structured and unstructured tokens, equipping it to extract, analyze, and contextualize this massive data ecosystem. So it doesn't just crunch data, it transforms it into insights, it extracts the answers, and it unravels the connection, letting you focus on what matters. If that's prior art search, risk mitigation, R&D planning and strategy, whatever it might be. So while competitors still manually annotate data and failing to keep up with the ever-increasing data volumes, or to a great fanfare just launched semantic search 8 years after Patsnap, or other arguably more competent AI competitors, hyper-focus on the top 10, top 20 results and tagging small volumes of patents, they miss critical comprehensiveness. So instead, we have built AI that addresses this problem with cutting-edge AI, and it operates within or in connection to the world's largest patent database nowadays, with nearly 200 million patents, 170 jurisdictions, 95 full text. That also happens to have the most academic journals of any patent intelligence solution, so 70 million full text, 200 million in total. Okay, so what is the solution to these challenges? Well, one of the big ones are compute. Okay, that was a little video I made, clipping together my most favorite AI, LLM, and in some examples, CNN visualizations. And yeah, it's truly fascinating. And sometimes this technology is described as word calculators, just predicting the next word. But I think people fail to realize just the level of intelligence of these systems. Like, let's consider an example from OpenAI's Ilya Sutskever. Say you have a detective novel with a complicated plot, a twisting storyline with lots of different characters, lots of events resulting in an unclear mystery. On the book's last page, the detective gathers all the clues, suspects, and announces, "I'm going to reveal the identity of who committed the crime." Imagine predicting the next word in that situation, right? It turns out that it can, and we can do more than what we ever thought was possible with these so-called word calculators. All right. So is compute all it takes? AI innovation emphasizes bigger models, more power. OpenAI is racing against xAI to build the biggest data centers with NVIDIA chips. But is that truly enough to deliver precision in a complex domain like IP and R&D? Well, as compute and data grows, we've seen that improvements diminish. We've been waiting for ChatGPT 5.0 now for a year and a half. It seems like these models hit practical limits despite the massive resources. There is a point where just looking at the averages, the most common answer will still produce inaccurate results. So there's some missing pieces here. It's the deep domain understanding. General models overlook things like claim dependencies, details hidden in the middle of the specification, summarizes technical content in a way that's too basic for a subject matter expert who's been working in a certain field for 20 years. Patents and technical info is interconnected. Legal interpretation is complex. Technology is nuanced. Solving this requires specialized intelligence, not just brute force. So here comes some of our solutions. Actually, so this causes a great concern, using AI in such a sort of sensitive field with critical risks. We have very high stakes in our fields. Mistakes are costly. Reliability is not optional. It's critical. We've all seen AI hallucinate, AI wrongly identify prior art, give bad results if you're asking it to look up patents. And that could lead to invalid patents or wasted resources. And these generic models, they often miss these nuanced concepts. Like, for example, like 112F claims. I recently did a test together with our ex-patent examiner at Patsnap, Matt Vale, and I asked Hero, the AI assistant, to judge if the first independent claim in this application was at risk for a 112F rejection. And it seemed to be a bit of a coin flip in terms of what interpretation it landed at. Then with ChatGPT, then I did the same thing, but with Hero, and it had a much greater accuracy according to an ex-examiner. And I think that's a testament to that. So, Patsnap GPT is built to reduce these errors, deliver reliable real-world results in a number of different ways. Okay, and the answer is specialization and a few other things. And why does this matter so much? Because precision, not generalization, is key to solving complex problems in our industries. So Patsnap GPT is fully fluent in understanding what makes a patent novel, what the inventive steps are, claim analysis, understands the domain deeply, and because of that, avoids common pitfalls. So this specialization means fewer errors and more trustworthy insights for critical decisions. And we achieve that through domain-specific models. I'll be showing you them shortly. Domain-specific data recipes, very carefully selected data pieces to produce more accurate, correct answers. And very importantly, subject matter expert data markup. So we've had real experts ranking, reviewing documents. We're going to look a little more into that shortly. And then finally, the final piece that's been proved to be increasingly important is domain-aware real-time knowledge retrieval, i.e. the AI needs to be able to accurately find the latest, most relevant information to a question, for example, and not kind of reference something that happened a few years ago or what the state of the art was a couple of years ago. All right. So not only do we have what's called like a Patsnap GPT. Patsnap GPT is kind of a trade name for three domain-specific models. They are all used sort of strategically throughout our platforms. It's Patent GPT, Pharma GPT, and Materials GPT that is in development. And let me tell you a little bit about them. So Patent GPT has 70 billion parameters. So it's highly refined for patent analysis. It surpasses GPT-4 in things like claim drafting, prior art search. It has 200 billion tokens, so it's trained on an extensive library of patents and IP data. It has a long context window because, as we all know, patent documents can be very long. And if you ever try to feed a patent document into ChatGPT, for example, you'll find that it very often kind of skips over things that's in the middle of the document. We've taken extra care when it comes to its attention throughout long contexts. Then we have this 100K PPO pairs, 30K SFT pairs. I'm going to talk more about that shortly, but that is essentially some statistics around how much expert-guided training we have in place to ensure precision and this domain focus. Pharm GPT has a ton of biosequences. It's fantastic at uncovering relationships between compounds and outcomes. It's world leading in figuring out antibody pairs, for example, in patent literature. And Materials GPT is very focused on predicting material behavior, optimized synthesis methods, and looks at things such as property unit and measurement, extraction, table extraction, process to property mapping, and things like that. Okay, and each one of these domain-specific models, they have their own unique domain-specific data recipe. So we have a two-stage training process, which is, and all our data that you have perhaps seen in our database is the foundation of our language model. Our data recipes are not just large, they're very curated, very targeted to address the complexities. It's been proven to be better to have a slightly smaller data set that is more reliable, more accurate, more specific to the domain in terms of reducing hallucinations and ensuring accuracy. All right. Then, of course, we also have academic papers, chemical structures, drug approvals, 1 million clinical trials, all that's been fed into the LLM. Here's a closer look at Patent GPT's data recipe breakdown. So not too surprisingly, patent data about half, papers around 25%. And what I think is one of the most crucial pieces, especially when it comes to claim interpretation, is the file wrapper data, giving it very accurate sort of direct to source understanding of examiners' sort of reviews and considerations and objections and so forth. Other things is also very important, such as textbooks and exams from patent or technology-related fields. Okay. The next piece here truly sets us apart. Larger generic models, they might do some subject matter expert fine-tuning, but they're dealing with every domain in the world. They have limitations. We've been able to employ this methodology specifically for the domains. And this reduces errors, hallucinations, enhances accuracy, and it builds a lot of trust. So, for example, we have what's called 30K supervised fine-tuning pairs for Patent GPT. So what does that mean? Well, that's the type of fine-tuning, that expert feedback, labeling, ranking, and so on, that enables the tool to do things like interpret claims correctly. Think of SFT pairs as like annotated examples crafted by domain experts. Like an expert might label how a specific phrase in a patent claims maps to a technical structure, teaching the model step by step how to handle those scenarios. A bit like mentoring a junior colleague, an expert guides the LLM through tricky claims, nuances, showing exactly how to navigate these complexities. And over time, the model becomes a top performer, learning from the best and resolving these challenges well. Then there are limits to just how many hours you can employ experts to sift through data and rank those. So what we've done is that we used AI to learn from the way that experts annotated data. And then we set the AI out to label even more data. So that's how we increase that. We have 100,000 proximal policy optimization pairs that way. This way we ensure a continuous improvement in these feedback loops. So PPOs are a bit like, so imagine you're a teacher reviewing homework. You just don't grade it. You provide feedback on mistakes and suggest improvements, and similar principles applies here. So if the AI misinterprets a dependency in a claim, PPO corrects it and adjusts the model's approach, and this ensures that the model learns from this feedback and improves its accuracy over time. Having this is also key. So today I'm not talking too much about security and confidentiality, something that I'm sure is on everyone's mind. Patsnap is unique. Our model, as it's our own proprietary model, is hosted within a regular web application. Data does not leave to go to sort of third parties, so your chain of trust is really short. We have full control of it, so we can show you, contractually guarantee, and have decided that our AI should never learn from customer data. And that's why subject matter expert data markup and AI AI subject matter expert data markup is so important to us. Okay. So yeah, Patsnap GPT isn't just smart, it's trained by experts to think like an expert. Through these annotated examples and data points, synthetic challenges, and continuous feedback, it delivers precision and expertise that general models find it hard to match. And this combination of domain expertise, this iterative refinement, that's what I believe makes Patsnap GPT stand out in terms of being able to deliver reliable, actionable insights for high-stakes fields. All right, so let's talk a little bit of results and proof of some of these claims. For example, Patent GPT outperforms GPT-4 on the patent agent exam, scoring 65 out of 100, which in the particular exam we had is a passing mark. versus ChatGPT's 56, which is a failing mark. It has 90.4 accuracy in identifying technical data, prior art, dependencies. Farm GPT has over 90% accuracy in biosequence alignment and drug interaction analysis. Materials GPT, which is a bit of a work in progress, is enabled by the 250 million data sets to enable precise predictions of structure property relationships. We're still working on benchmarks for materials GPT. So Patsnap GPT isn't just trained, it's proven, it's tested, it delivers consistent results in real world applications. One of the ways that we've been able to benchmark the tool is through specialized benchmarks like MOSIP. For a long time, there were no kind of patent or intellectual property specific tests, so to speak, so benchmarks for large language models. But thankfully, this year it was released, and the proof is in the pudding. Patent GPT greatly outperforms other models. Okay. Some other things that might be worth mentioning is a 20% improvement in patent recall, 16% improvement in cross-language accuracy. I don't know if you ever looked up just what percent of patent filings are coming from, for example, China. Well, it's a very large percentage. I think in terms of raw documents in 2023, my estimates are a little bit higher than WIPO's, who recently became a Patsnap customer, by the way. So maybe this will change. But yeah, I get it to around 78% of filings in terms of number of actual documents came from China in 2023, which is a remarkable number. So technical matching performance, so identifying relationships between technical components. We saw an 18% improvement there too. And a fun number is that we fed the model with 55,000 patent-specific terms. So much better at handling industry-specific and legal language more accurately than general models. Okay, so this is kind of the base model. But there's a little bit more that's required for true excellence, and that is what's called RAG most often, domain-aware real-time knowledge retrieval. Essentially, the AI is doing a search, and what I've seen personally, I don't know if you share this sentiment, but if you look at Perplexity, if you use OpenAI's search, it seems like the search component is a critical kind of failure point for those models. They're getting kind of surface data, they don't go deep, they don't have the type of access to patent and journal database that we have, or at least their search algorithms isn't returning results from them. So by implementing RAG throughout in the model implementation in the platform, we can ensure that the AI is basing its answers on the latest up-to-date information and it's accurate. Next bit is a little bit technical, but we have invented a patent-specific SQL generation. So that means we have a unique way of transforming a patent text to a database query to retrieve results. We have 100 billion plus vector search capacity. And we also have a domain-specific search model. I mentioned Patsnap semantic search. We've had it since 2017, and we've made a huge improvement to it. We do it each year, but this year we saw even better results than before through our X embedding innovation. And here, in this context of retrieving information based on natural language from a database for a machine to interpret, this is where our kind of USP or approach to semantic search, an approach we decided on long before we decided to launch Patsnap GPT, has really paid off. Because our semantic search is very focused on comprehensiveness. We're trying to make sure that a semantic search can truly uncover all the relevant records in a field. That's the top priority. Sure, we definitely optimize it to have like top 5, top 10, top 20 results. That's super important. But yeah, the unique differentiator, I'd say, with our semantic model is just how comprehensive the total result set is. And this is extremely beneficial for a machine that doesn't need to limit its top results. It doesn't need to just read 10 patterns due to time constraints. It can process it all. So yeah, thanks to our semantic search, thanks to this RAG implementation, you get live, up-to-date, reliable, correct information. All right. I wasn't able to look at the chat as I went through my presentation, so I'm going to have a little look now to see if there's some questions here. Okay, what are your thoughts on training models on internal technical documents, experiment data, trade secret data? And I have to click the read more button. And for companies that have been around for decades and have amassed this specialized proprietary data, this might be incredibly valuable. Absolutely, it is. And entrusting this data to an external system is usually a really sensitive topic. Patsnap has, we already have a number of customers, but we are currently kind of developing our capability further to have like an off-the-shelf and not customized solution for on-premises use of Patent GPT, Farm GPT. It looks like we're going to have 2 different levels. One is to have it fully on site, you have the model and everything. Then second is kind of like halfway in between, where you the model is external, but your data sits internally. And then also in development, or is a finished product, but I don't think we have fully launched it yet, is what we call API agents. So that's agents that can perform specific tasks, analyze data in particular ways, and all you have to do is to make an API call, making that integration with our model much, much easier without having to take that step to go fully on-prem. That takes a little while. There's definitely a lot of customization that goes into it. Also a solution that tends to be on the expensive side versus just using a platform, for example. Okay. So yeah, speak to your Patsnap sales representative about that. We are ready to provide you with those services, even though we haven't fully gone to market with them yet. Yeah, you said something. Here's another question. You said something like, we never learn from customers' prompt. That's nice. Which security measures have you implemented to ensure this privacy principle? Well, it's kind of, I get this question sometimes, and it's really simple. It's just by complete separation between customer data and the training data. Your customer data is encrypted in AWS, either in Frankfurt, if you prefer that, or in North Virginia, if you might be a US company, and and that data is encrypted at rest there, and it's never accessed by Patsnap. We don't take it into our testing environment or training environment for our LLM. The only way that data comes in and out of the encryption is if you use the platform. Then there's an automated program that has the permission to just grab the data just for you and send it back to you. So yeah, it's just so entirely separate. Some other things that are kind of tangentially related is that we also try our utmost whenever possible, whenever feasible or desirable for a feature, to not even store your prompts. So for example, if you go into, let's take something basic like a regular semantic search in Patsnap. If you go in, you put in text, and you press search, then that text isn't stored in your history. You can go back and see your input, but that's stored on a cookie level, like on a local browser level. So the only thing we store is like a hashed representation of your input. So kind of what the algorithmic recipe was to deliver you certain data. We can't actually, we don't have that original text even in the system. Same goes for Hero. If you open up Hero in a chat page on Patent View, for example, then its memory and its storage of your chat is entirely session-based, which means that as long as you're there in that chat window or leave that open, it's going to be there. But if you close that down or refresh the page, that will be, it's just disappeared. So we kind of, that way we stop this problem before we even have to decide to keep your data separate, if that makes sense, by simply not storing it. Confidentiality and privacy is critical to gain the trust from our customers. And in our domain, in innovation, in legal IP, you just can't have a model that learns from customer data. No one would use it, or at least I hope not. Okay, those were the questions that I've seen in chat. I hope this session was useful. Again, please feel free to reach out. I stayed away from some of our roadmap items because I think it's quite a sensitive topic when it comes to how we're going to push our LLM further. But I can say that we are looking to make it bigger, better, include more data and better capabilities and more expert fine-tuning, basically better all around, more of everything. And we have a very aggressive roadmap plan for 2025. So stay tuned. Thank you.
Awesome. Thank you so much, Carl. I think that was a super fascinating look under the, quote unquote hood of Patsnap's proprietary LLM.